Good morning, children. I welcome you all to today's session of chemistry, and we are on to the chapter metals and non-metals, and we were on to the topic electronic theory of valency, and we have seen that Cossel and Lewis gave this theory, and they said that all the metals tend to reach the inert gas configuration, which is shown in this table as to be having 8 electrons with only helium having 2 electrons. Right, certain rules were suggested. First was Octet Rule, which says that the tendency of atom to achieve 8 electrons in their outermost orbit. Right, you need to remember this point, that 8 electrons is known as the Octet Rule. This rule was on the basis of electronic theory of valency, which suggests that according to this theory, during the formation of a chemical bond, atoms combine together by gaining, losing, or sharing electrons in such a way that they acquire a noble gas configuration. Right, so this is a very important theory, children, which you should remember. Now, valency and valence electrons, you can see here that if the number of electrons in lithium is 3, then 2 electrons first go to K shell and the remaining electrons goes to the L shell, and L shell electrons, they are the valency electrons. For beryllium it is again 2 2, so 2 electrons go to the valence, and boron 2 3, and so on and so forth. Right, and these electrons are shown as dot, as you can see here. Lithium, beryllium, dots are there. Like in nitrogen, right, you can count here. In nitrogen there are how many see, 5 at the top. There are 2, then 1 3, 1 4, and 1 5. Right, so there are 5 electrons in nitrogen. Now we come to the chemical bonding. There are three types of bonding: by losing or gaining of electrons, by sharing of electrons between two atoms, but shared electrons are contributed only by one atom only. These three ways result in establishing some sort of binding force or chemical bonding between them, right? So the first one, by gaining or losing or electron, is the ionic or electrovalent bond, right? Basically this is shown by those elements which have one or two electrons in the outermost orbit, along with those atoms which have 6 or 7 electrons, which means they need 1 or 2 electrons to complete their octet. Right, and basically mainly primarily these. Now see here, some electropositive ions are shown in this chart. You can see here in this first list there is hydrogen, lithium, sodium, potassium, cuprous, silver, and mercurous. And the second one, bivalent: calcium, cupric, zinc, mercury, ferrous, magnesium, and lead. Trivalent: aluminium, ferric, and tetravalent: lead, plumbic or stannic, or platinum. Now some electronegative: chloride, bromide, iodide, nitrite, nitrate, hydroxide, acetate, carbonate, oxide, sulfide, and so on. Trivalent: nitrite, phosphate, and tetravalent: carbide and ferrocyanide. Right, now example, let's see here how ionic bond is formed. Right, Na is having 281 configuration and Cl is having 287. So Na is having 1 electron in their outermost orbit and Cl is having 7. Now see here how sodium donates 1 electron to chlorine, which is indicated by this arrow. Right, and this is how, now this electron in the outermost orbit of sodium, it now moves to chlorine. See, I am referring to this electron which is here. It goes on to chlorine. So now chlorine is having 8 electrons, and sodium, after losing the last electron, it's left with 2 comma 8, which is 8. So both of the elements attain the inert gas configuration, and so on. Na2S is also formed in the same way, with 2 atoms of sodium giving 2 1 electron each to sulfur. And there are other elements have been shown here. Now we come to the properties of ionic compound. First is physical state. They usually exist as crystalline solid. Strong electrostatic force between the positively charged holds them close. They are somewhat hard because of strong force of attraction. High melting and boiling point electrostatic force which held opposite ions together are very strong, so it requires a very high temperature to overcome these forces. Ions attain the freedom of movement as in a liquid at high temperature. Therefore, the melting points and the boiling points of ionic compounds are very high. Solubility in water. Water has high dielectric constant and weakens the electrostatic force of attraction between the ions. Thus, they are dissolved in water. Electric conductivity are unable to conduct electricity in solid state because movement of ions is very restricted, right? Because the structure is very rigid. Now, these metals, they occur in the form of minerals and ores. You can see the oxide ores are Fe2O3 hematite, Fe3O4 is magnetite. Now, remember this Fe2O3, right, children? This is super duper because this is what magnet is. Magnetite is basically magnet. Then zincite. Then there are cuprite and bauxite also. Then there are carbonates also, sulfates, fluoride, chloride, nitrates, phosphates, silicates, sulfides. All these are ores which are there. Now, how metals is extracted? The process of extraction of metal is called metallurgy, right? And most of the elements are found as oxides because oxygen is found very near to the earth crust, right? Now, metals can divided into three groups: highly reactive, medium reactive, and low reactive. Right? See, there are three main processes: concentration of ore, conversion of ore into metal, and refining of impure metal. These are the three main processes of involved in the metallurgy. These three. Now, first one, see how ore is then concentration of ore is then it comes to the three kinds of metals, and this process starts. First, concentration of ore, enrichment of ore. In this, ore usually contains soil, sand, and other things. These unwanted impurities present in ores are called gangue or matrix. The removal of these impurities from ore is called concentration of ore. The methods used for removing gangue from ore depends on some differences in the physical or chemical properties of the ore and gangue. Before the ore is subjected to concentrated, it is crushed into small pieces, right, in a crusher, and then the ore is now converted into metal. Different methods are used for extracting of metal from ore. For low activity series, right, and then see by oxygen heating with oxygen, this thing happens. As you can see for the cases of mercury, copper, when heated with oxygen, right, it forms mercurous oxide and sulfur dioxide, and this mercurous oxide further on heating gives mercury and oxygen. Now, middle activity series, zinc sulfide with oxygen, we get oxide ore, and carbonates, when we heat we get oxide ores. The reduction of metallic ore, this is done by reducing agents. Now in that the oxide goes and mixes with the reducing agent and the metal is left alone. And then, now this is very important, thermite reaction. It reduction of a metal oxide to form, I'm referring to this reaction here, children. Thermite reaction. Now in thermite reaction, the reduction of a metal oxide to form metal by using aluminium powder is called thermite reaction. This property is made in thermite welding for joining broken pieces of heavy iron objects like railway tracks and cracked machine parts. Right, so basically this is used in welding also. Extraction of metal towards the top of the activity series is done by electrolysis, electrolytic reduction through electrolysis, and then refining of metals is done by electrolytic refining. We have one cathode and anode, and then the entire process of electrolysis occurs here, right? Okay, now this is Now we come to rust. Rust, see, this is the formula of rust. You need to remember it. Write this formula: 2Fe2O3 dot 3H2O, right, with a small quantity of ferrous carbonate. Now prevention of corrosion can be done. Corrosion or rusting is a surface phenomenon, and thus it can be done by applying paints or enamels, also by forming firm and coherent protecting coating of ferrous oxide, and third is by coating film of zinc, nickel, tin, or chromium or aluminum. Now what is an alloy? Alloy is formed by mixing two metals in a particular ratio. It improves the properties of metals, right, and most sometimes it also reduces the cost. Amalgam, if one of the metal is mercury, then the alloy is called amalgam, right? Okay. Now iron pillar near Sarnath, which is it contains a thin film of magnetic oxide is there. So that we come to the end of this chapter. I hope you enjoyed it as much as I did in making it, and until we meet again, it's a goodbye.